Okay, so we are going to continue the basic statistics, which is useful for the data analysis. Okay, so this is the second week of the basic statistics. All right, so we are going to talk about study t-score. Remember we did z-score last week. T-score is a little bit similar to z-score. All right, then using this t-score, we're gonna do the hypothesis test. All right. So this is a formula for t-score, a little bit similar to z, but I want you to know that t-score is used for sampling and z-score is for population. So I hope you know the difference between population and the sample. Um, Population is like everybody, um, everybody for the how can I say? Sample is just the sum of the population, right? Okay, so when you do some analysis, population data is really difficult to get because you have to get all the data, right? So a lot of times, most of the time, we use just a sample for the data analysis, okay? So t-score is more often used than z-score because of the nature of the data, okay? Then this is a hypothesis. So we have null hypothesis. That means there's no difference. Okay. So for example, there's no difference between people in Bangkok and the people in Chiang Mai. There's no difference. Or alternative hypothesis is that the null hypothesis is false. So that means people in Bangkok is not the same as people in Chiang Mai, such as such. All right. Uh, then this is how we do the hypothesis testing. So first we calculate the t-score using this formula, all right? Then using t-score, we change to the p-value, which is t distribution, the percentile distribution, all right? Then if p-value is less than 5%, okay, so you need to remember this magic number 5%. Then reject the null hypothesis, meaning that the null hypothesis means the same. So you reject that they are the same, meaning that they are different. Okay. Otherwise, fail to reject a null. 5%. Where does this 5% come from, right? So remember we did this little bit normal distribution. Okay. Then this is on the left hand side. There's a 2.5% and there's 2.5% together, 5%. If your sample falls in this blue area, then they are statistically different from rest of the data. Okay, remember this in the center it's a mean. If it's not in 5%, then you are in this green zone, which means we assume that they are the same. Okay. Well, let's try look at the example. Maybe that's easier to understand. Okay. All right. So this is data we are going to use today. Does it come? Okay. Okay. So number of national holidays differ country by country. Okay. So this is a list of the country with most holidays in the world. Okay. So you know which country has the most holiday. Then according to this data, the country which has the most public holiday is Cambodia. Within 1 year, there's 28 days, and next one is Sri Lanka and so on. Okay, so I just copy this, copy this, copy this data, copy, then I put it in the Excel file. Okay. All right. Okay. Okay. So now we need to calculate. This t-score, right? Remember, we need to first calculate the t-score. Okay. So what do we need? Okay. All right. So we need average, right? So how many days average holiday? Okay. Average. Then we take this. among these countries, how many public holidays? 17 days. Okay, then there's a standard deviation. We need to calculate the standard deviation. Is STD, right? Standard deviation. Okay. Then number of sample. We need to know how many sample are there, which means this n. Okay. We need to count. This formula just count how many numbers are there. Okay. So 11. Okay. So now we want to compare. We need to compare this to average number of holidays in Europe. So most of this country, I think, is in Asia, I think. Cambodia, Sri Lanka, India. Okay. So we want to know how many holidays are there in Europe. Okay. Then does it come? Okay. Dun, dun, dun. Okay. So in Europe, they have 25. Okay. So they already calculated for us. Okay. So this is 25. Average in Europe. Okay, then it's 25. Okay, so now we want to know if this average is statistically different from this average here in Asia. Looks different, but is it really different with statistical analysis? All right. So we need t-score. All right. So t-score is equal to this is a formula. Okay. So x bar is this number is average. I mean average in Europe minus mu is this number. Okay. Then divided by standard deviation. All right. Divided by square root of n is number of sample. Okay. So I just do this. Okay. So it's 4.7. So next, this 4.7 we change to p-value. All right. Okay. So p-value is you need t distribution. Okay. T distribution. T distribution. Okay. Then this x is this t-score, but we need absolute number. So ABS of this t-score, right? Then degree of freedom is always number minus 1. I just want you to remember. All right. Then tail is 2. 2 tail and 1 tail. Okay. 2 tail, 1 tail means, so this is just 1 tail. This is 1, 2, 2 tail. All right. I just want you to remember. So now we have p-value. Okay. So it's only like a 0.08%. All right. So remember our rule is that if p-value is less than 5, then reject the hypothesis. Okay. So this one, reject the null hypothesis. Okay. So what is it? Null hypothesis, they are the same. So average holiday average number of holidays in Asia is different, right? Because no hypothesis assume the same and we reject it. Okay, so average number of the hypothesis of holidays in Asia different from that of Europe. Okay, so that's what we do. Okay, how about we compare holiday in Thailand. Let's see. So how many holidays are there in Thailand? Actually, already here. How many is it? 16. All right. So it's 16. So we use all the number the same. So copy. We cannot copy this. Okay. So use this number. Use this number. And again, use this number. Here you go. Okay. Then these are the same too. These are the same too. So t square and p value. Copy. Okay. Then t square is this time is negative 0.7. Then p value is 45%. Okay. So this one is fail to reject the null hypothesis. And what does it mean? Meaning that average number of Asia is the same as in Thailand. Remember, null hypothesis assumed that they are the same. Okay, and we fail to reject. That means we take the null hypothesis, meaning that these holidays in Thailand 16 and average 17, they look the same, but how is it really the same? Like statistically, then we conclude that they are the same. All right. So that's what we do for the t-score. All right. I stop just here.